Alfred Büchi, an engineer from Switzerland, is seen as the inventor of the turbocharger. At the time of its invention, and today, the turbo's purpose is to take advantage of the exhaust gas produced by the engine. Today, small airplanes and light aircraft are equipped with a turbo to remedy the problem of low air pressure in higher altitudes. Ships and boats also use turbocharged engines, just like most diesel engines of cars do. In a standard 4-stroke diesel engine, air is forced into the cylinder by atmospheric pressure. This is the reason why this kind of engine is known as a naturally aspirated engine. At times of high RPM, for example on the highway, the atmospheric pressure will not push enough air into the cylinder. Consequently, the engine cannot run efficiently. Here, the turbocharger comes into play. A standard turbo, as it is used in boats, airplanes and cars, is composed of a shaft with a turbine wheel on one end and a compressor wheel on the other end. The turbine wheel and the compressor wheel may look the same and are covered by a housing. The exhaust gas produced by the engine enters the turbine housing through the inlet port. At that point, thermal energy is converted into kinetic energy because of the constriction in the turbine. Consequently, the turbine is driven by kinetic energy. As the turbine wheel and the compressor wheel share the same shaft, the compressor wheel spins at the same speed as the turbine wheel. Consequently, the compressor wheel draws in air and compresses it. Then, the air passes through the outlet port and supplies the engine with oxygen. Let's have a look at the turbo and other components to have a better idea of the principle at work. The exhaust gas enters the turbine through the inlet port, drives the turbine wheel, and exits the turbine through the outlet port. Hereby, the compressor wheel draws in air, compresses the air, and pushes it to the engine. Engines that have a turbo are known as turbocharged engines. A turbo only works efficiently if other components are part of the entire system. We need, for example, an intercooler because the air heats up when it's compressed. So the intercooler will cool down the hot air coming from the compressor, ensuring that more oxygen reaches the engine. That makes the engine much more efficient. Furthermore, a valve, which is also known as a wastegate, is used to divert exhaust gas away from the turbine when too much exhaust gas is produced by the engine. So it limits the rotational speed of the turbine wheel and consequently the compressor wheel so that the turbocharger won't be damaged.
Centrifugal compressors are used in motorcycles like the Kawasaki H2, but also in cars. They possess a housing into which a compressor impeller is installed. As soon as the impeller rotates, it acts like a reversed fan and draws the surrounding air in. You can see it here because of the small cotton balls. Speeds of more than 100,000 revolutions per minute are not uncommon for these impellers. Air is drawn in extremely quickly in centrifugal compressors. When it exits, however, we see that the speed of the air has slowed down greatly, but there has been a major increase in its density. As this is quite important, we will get back to this again later. Centrifugal compressors are driven by V-belts or toothed belts, but chain drives, as used herein, are also possible. A planetary gear is suitable for achieving high rotational speeds of more than 100,000 revolutions per minute. A similar one is also built into the H2. The small gear wheel in the center, the so-called sun wheel, is connected to the compressor impeller. The ring gear is driven by the gear wheel, which is connected by a chain to another larger gear wheel, which in turn is driven directly via the engine's crankshaft. The outlet of the compressor's housing is connected to the inlet of the engine. As soon as the engine starts running, it drives the compressor, and the compressor thus provides the engine with compressed air. This allows the engine to burn more fuel and thus can provide greater performance. In the H2 motorcycle, the air is blown in from the front, while riding is routed to the compressor and finally to the engine. Since air is heated by compression, intercoolers are often used. In the case of the H2, however, there is no need for such a device. One of the first vehicles with a Roots blower was the Bugatti Type 35, which was developed in the 1920s. The heart of the Roots Type Supercharger or blower is the rotor. Roots blower rotors are available in different designs. They can be equipped with twisted lobes, for example. But they also come with straight lobes. First, we look at a very simple variant with straight lobes. The housing has 2 inlet ports and 1 exhaust port. The rotors have 3 straight lobes and do not touch each other. A gear wheel transmits the rotational motion. To better understand the airflow, we simply pass a colored liquid through the blower. This allows us to easily understand how the lobes convey the fluid from the suction side to the pressure side. Roots blowers used in cars usually have rotors with twisted lobes to ensure low vibration and quiet operation. Touching rotors are also not desirable here because the resulting heat would cause the supercharger to fail due to seizure or jamming. Via an air inlet equipped with an air filter, the ambient air reaches the rotors through a pipe, which transports the air downwards. In hot rods, muscle cars, and other souped-up sports cars, the air intake often protrudes from the hood. Usually, an additional intercooler is installed below the Roots-type blower, where the outlet port for the compressed air is situated. The air passes through the fine metal elements that have water running through them. Thus, the air can release its high temperature created through compression to the water. The cooling occurs because hot air takes up more space. As the air gets cooled, the molecules contract. Rotation is transferred, as mentioned above, through a gear that drives another gear, since the rotors themselves must not touch each other. The rotors can then be set in motion by a belt, which is driven, for example, by the crankshaft. The air from the blower can enter the combustion chambers of the engine via the pipes shown in green, thus burning more fuel than a suction engine. As already mentioned, it is useful to cool the air so that more oxygen can be pushed into the combustion chambers.